Students, hope you have understood the concept behind the velocity analysis by using the incidence centimeter. In this session, let us practice one simple problem, 4-bar mechanism. Here, as shown in the diagram, there are 4 links. The AD is a fixed link. The other links are the lengths are given. So the AB is at 60 degree from the fixed link at this instant. Now we have to find the velocity of the link, angular velocity of the link BC. So we have to determine. Now as per the scale determined, we have to draw the space diagram by using the suitable scale. Next, we have to follow the method. First method, the first step is find the number of instantaneous center. We know the formula n into n minus 1 divided by 2. We know there are 6 instantaneous centers for this 4-link mechanism. Now you have to draw the bookkeeping table as shown in the previous session. So locate all the write all the possible instantaneous centers and you tick mark the instantaneous center that have been marked on the space diagram. Now we can easily fix I12, I14, that is permanent fixed instantaneous center, and I23 and I34 fixed instantaneous center. Now we have to locate I13 and I24. So for this, the circle diagram can be used. Here, by using the circle diagram, the I24 is the junction of the two pairs I23 and I24 and I12, I14. So by on extending, the lines meet at a point, this I24. Similarly, I13. So it is a junction of the two pairs of instantaneous center I12, I23 and I34, I14 can be understood from the circle diagram. See, it is similar to the session described in the previous session. So I13 and I24. So from this, all the instantaneous centers have been located. Next, the part is to determine the velocity, angular velocity of the link BC. Now, the link AD is fixed and the AB can the link AB from this link AB, the velocity of the B is determined by using the formula R omega. Here R is the length of the link AB, omega is given. So from this, yes, we can calculate the velocity of the point B. Now, from this diagram, now the B is a common point to the links AB and the BC. From the second link AB, we can calculate the point B. That is, the B is assumed to lie on the link 2, that is AB. Now, we can have the velocity of B by using the formula R omega. Here R is the I12, I23, that is the length of the link AB. Now, again, we consider the link B. Now, it is now, and the consider the link B lie on the link BC. Here, in the B is rotating about the center I13. So, for this, when we consider the link BC, now we have to consider the radius of rotation I13B, because for various positions, the B is moving to a newer positions by the rotation by the distance of I13B. So you have to consider the distance I13B. So here it is written. Now from the configuration, we can calculate the geometry I13B equal to, it was found that 500 mm, that is 0.5. Now the velocity of the vector BB equal to R into omega. So the omega can be written as velocity by the R, that is velocity of point B. Now already we have found the velocity of the point B by considering the link 2. Now here the velocity of the point B in link 2 omega angular velocity of link AB and the length of the link 3.141 meter per second. Now from the point, consider the point B which lies on the link BC, so it can be rewritten as omega equal to B by R, that is VBR. So here the radius of rotation is I13B. Now by the measurement we have I13B is 0.5 meter. So on the division we get 6.282. So now we have found the angular velocity of the link BC here. So one more consideration is that, so the compared to the relative velocity method, it will be the instantaneous centimeters will be time consuming if the number of links exceed the 4 links. It's only problem. So it is very quite easy. So in this session, we have solved one simple problem by using the instantaneous method. Thank you, students.